Today I will teach coding theory in the ANOVA. Coding method is one of the easiest method, one of the shortcut method for finding F ratio. In this theory, based on an important properties of F ratio. That property is we have n observations. That n items are either multiplied, divide, subtract or added by a common number from each of the observation. That means we have x1, x2, x3, x4, etc. xn, n observation. So these n observations multiplied by a common number. We can multiply 5. So n observations we can multiply by 5. Then we got 5x1, 5x2, 5x3. Then these observations, we used these observations, then finding F ratio, no change in the F ratio. Similarly, you have 2, 3, 4, 5. That means 2, 3, 4, 5. You have 4 observations. These 4 observations, you can multiply a common number 5. You got 10, 15, 20, 25. If you need to find 2, 3, 4, 5. So instead of 2, 3, 4, 5, these 4 observations, you used 10, 15, 20, 25. You get F ratio. These F ratios can't change. Similarly, you can multiply it by common number. Similarly, you can multiply it by a common number. Similarly, you can multiply divided by common number. You can subtract a common number. You can add a common number. No change in the F ratio. This property used in the coding theory. These operations, common number added our observations or common number subtracted from observations or common number multiplied by our observations or common number divided by our observations. These one of the 4 operations we can do, no disturbance in the F ratio. This property we used in the coding theory for finding calculated F ratio. Next, one of the problem for using coding theory, following data related to the yield of 4 varieties of wheat, each sown on 5 plots. Find whether there is significant difference between the mean yield of these varieties. Given that 5 plots and 4 varieties. This observation, first variety is this, second variety is this, third variety and fourth variety. So we have 4 varieties in the 5 plots. So you need to find significant difference between the mean yield of the varieties. So in this data, we using coding theory. So here we know we get each observations are near to 100. Here 99, 103, 109, 104, 101, 103, 99, 98. Each observations are near to 100. So I will do each observations subtract from 100. So first observation, subtract from 100, you got 99 minus 100. 103 minus 100. 109 minus 100. 104 minus 100. So you got these. First one, minus 1, 1, 3, minus 1, minus 2. 3, 2, 0, 5, minus 5. 9, 3, 7, minus 3, minus 1. 4, 0, 3, 7, 6. Here, given observations, 4 varieties and 5 plots. Each observations are near to 100. So, I used coding theory. So, I got each observations near to 100. So, I subtract from each observations and 100. So, I got new observations. New observations are smaller than given observation. So, we can do more easily. So, I find out column total. And one-way classification. First, I need to find T. T means total number of observations. Otherwise, we can take a total number of columns into total number of rows. Total number of columns is 4 and total number of rows is 5. So, T is 5 into 4. 20. Sorry, not T, N. Sorry. N is 5 into 4. N is total number of observations. Next, T is sum of the observation. So, you take all observations and add it. So, here minus 1, 1, 3, minus 1, minus 2, 3, 2, 0, 5, minus 5, 9, 3, 7. All observations you add it. Minus 1 plus 3 minus 1 minus 2 plus 3 plus 2 plus 0 plus 5 minus 5 plus 9 plus 3 plus 7 minus 3 minus 1 plus 4 plus 0 plus 3 plus 7 plus 6. So, you add each observations, you got 40. So, T equal to 40. N equal to 20. Next, you find T square by N. T square by N is 40 square by 20. So, 1600 divided by 20. You got 80. T square by N is 80. Next, you find SST. SST equal to sum of the square observations, minus T square by N. So, sum of the square observation means each observations you take and square it. Then add it. So, here minus 1 square plus 1 plus square 3 square minus 1 square minus 2 square etc. 6 square. That means here minus 1, 3 minus 1, 2 minus 2. So, you square minus 1 square plus 1 square plus 3 square plus minus 1 square plus. So, you got 6 square minus T square by N. You got sum of the square is 338 minus T square by N is 80. So, 338 minus 80 is 258. So, you got SST is 258. Next, SSC. SSC is summation of x1 square by n1 plus summation of x2 square by n2 plus summation of x3 square by n3 plus summation of x4 square by n4 minus t square by n. So, summation of x1 is 0 by n1 plus summation x2, x1 is 0, x2 is 5, x3 is 15, x4 is 20. So, 5 square by 5 plus here 5. 15 square by 5 plus 20 square by 5 minus 80. You know, t square by n is 80. So, here you got a 0. 5 square 25 by 5 is 5 plus 225 by 5 plus 400 by 5 minus 80. So, you got 0 plus 5 plus 45 plus 80 minus 80. So, you got 50. SSC equal to 50. So, SSE you got, SST you got 258. SSC got 50. Next, SSE is SST minus SSC. SSC is 50. SST is 258. So, 258 minus 50, 208. SSE is 208. Next, you find MSC. MSC equal to SSC divided by K minus 1. SSC is 50. K is number of observations. K is total treatments. Here K equal to 4 minus 1. 4 varieties. So 4 minus 1. So 50 by 3. That is equal to 16.67. So MSC is 16.67. Next, MSE is SSE divided by N minus K. So SSE you got 208 divided by N 20 minus 4. So 208 by 16, 1, 3. So you got all one-way classification procedures. Next you can write down the ANOVA table. So ANOVA table, source of variation, sum of square, degree of freedom, next mean square. So here between sample, within sample and total. Between sample SSC. SSC you got 50 and SSE you got 208. SST is 258. Next K minus 1 is 3. K is 4. 4 minus 1 3. N minus K. Within sample degree of freedom N minus K is 13. Next MSC equal to 16.67. MSE equal to 30. So N minus 1 is 90. N minus 1 is total. Degree of freedom is N minus 1, that is 19. So you got ANOVA table. Next you can find F ratio. What is F? F is MSC divided by MSE. What is MSE? 16.67 divided by 30. That is 1.28. So calculated F value is 1.28. Then you take a degree of freedom. Degree of freedom is K minus 1, comma N minus K. K minus 1 is 3 and n minus k is 330. This is degree of freedom. Level of significance, this problem not given. So we take level of significance 5%, that is 0.05. So you take a F table, statistical table and F table page, and you got degree of freedom is 330 corresponding to 330. N1 is 3 and N2 is 13. You got table value of F. That table value of F is 3.24. So table value of F is 3.24. Calculated value of F is 1.28. So here calculated value less than tabled value. So therefore we can accept null hypothesis. We can accept null hypothesis. Null hypothesis is there is no significant difference between mean yield of these varieties. So there is no significant difference between mean yield of these varieties. That is our null hypothesis is, first we assume null hypothesis. Our null hypothesis is our H naught is there is no difference between means. Mu1, mu2, mu3, mu4 are the means of 4 samples, that both of them are equal. No difference between these samples. Same samples mean. So here we got the null calculated value less than tabled value. So accept null hypothesis. That means there is no significant difference between mean of 4 samples.